Okay, I'm going to take you through how to use Bridge Designer software. To start, you just go down here to the bottom and type Bridge, and it'll give you the application that is installed on the computer. You select the Bridge Designer, and as it comes up, it's going to start by giving you some design tips of the day, and you can go through and read through some of these tips. They can be helpful for you. Okay, you go next, 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 and you can go through them. If you're really not interested in that, you can close it. Then we got our welcome screen here. From here you can create a new design, which is what we're going to do to start with. You could load a sample design. It's a design that's already been made, but we don't want to do that. Or you can load an existing bridge or file. So if you've already created one and you want to just bring it back up, you can go from there. And or you can always go through your file and open it that way. Okay, we're going to do a new design. I'll say okay. Here you're going to see the road design requirement. This is actually a competition that's been done throughout the United States. And kids will go through and they'll design bridges and they'll submit them and they'll do a competition with it. It's kind of cool. Obviously, we're not going to be doing the competition nationwide. We'll be doing it between us. But this gives you an idea of what the terrain that we're working with is. Okay, you can see that there's a big draw that is 44 meters wide by 24 meters tall. Shows you the slope here. Okay, 1/2 there. You can see basically we need to get a bridge across there, and as I said, I want to get it as cheap as possible. Okay, so we can go next here. Takes us to the next screen. Again, this is local contest information. If we were doing that, we can put in do some stuff with that, but we're not, so we can skip over that. Now, here's where we can get started with kind of setting up our bridge. We can adjust the deck elevation here. This is called the deck. We can adjust the deck elevation down or up. But I want you to notice that as we progress down, there is a site cost right here. Current site cost is $62,700. If I go down to 20 meters, that cost goes up. That cost goes up because you notice here in our legend right here, it's showing this pattern is called excavation. Excavation means basically they're having to excavate out the dirt and try to get the road base down to that level. So it's going to take more equipment, more cost. If I proceed to go down, the cost goes up as well. However, we are now spanning less of a distance. And if you remember, we talked about dead load and the materials. If we're spanning less distance, we have less materials. So we're going to have to weigh what is going to be the best solution. Do I excavate down and take that cost, or do I find a certain one of these areas that's perfect for me? That's going to be up for you to figure out. Okay, I'll start right. Let's go to 16. I'll start on 16. You can also change standard abutments and arch abutments. These right here are called your abutments. This is called an arch abutment. You see that? And this is a standard. And again, on the arch, you can adjust the height of those abutments. Each one gains in cost. You can see, right? I'm going to stick with a standard abutment for today. You can add piers, but we're not going to do that. That will allow kind of a anchor point for your bridge. in the middle, but in our situation, we're going to go with no pier. You can also do a 1 cable anchor or a 2 cable anchor. This is similar to having like a suspension bridge. Okay, if you were going to design a suspension bridge, you would have an anchor out here. I am going to do what's called a truss bridge on this one, so I'm not going to do a suspension type bridge. So I'm going to go no cable anchorage. Okay, say next. Then I can adjust my deck material from a medium strength concrete to a high strength concrete. Again, if I change that, the cost goes up. You can tinker with that however you want. I'm just going to leave it for now. The load, we got a standard truck or centered or 2-lane. I always just leave it on that standard. Okay, and then we go next. This gives us some basic templates to follow. You don't have to do this. The fun part of this is you design your own thing. Okay, but for this instance, I'm going to show you how. This is what's called a through Pratt. So basically the traffic's driving through the bridge. So it's called a how, I'm sorry. And if you notice the Pratt, the diagonal braces here are going to change from inward to outward. You see that? So that's the difference between a Pratt and a Warren. So actually I'm going to go with a how here. Sorry, how and Pratt. A Warren looks like this. Okay, it's just consecutive triangles. So I'll go with the how. The deck truss means it goes underneath the deck. Okay. So I'm going to do a through truss and a how. Say next. I can put my name in here. Who was designed by. Okay. And say finish. So I'm going to go ahead and start adding. There's 2 things that you need. Right here is called a joint tool, where I'm putting in joints, and you almost think of it as a weld. If I'm putting 2 pieces together or I'm combining 2 pieces together, that's the joint, and that's where it's going to get welded together, fastened together. So I'll select the joint tool and I just go along and I click, and again I'm just following this template. I click on where all the joints need to be. There's already some on the bridge deck there. Okay, then I can go into members. You'll notice this is called my member list and member details right here, and you're going to see I can click and drag. I click and drag, and that puts a member in there. Each time I put a member in, you're going to see that detail or list come right here. This one says it's number 1. I just keep dragging and putting them in there. And you build your bridge member by member. Okay? And every time I put one in, it adds the detail information over here. It tells you the material type. It says CS, that stands for carbon steel. If you notice, it says carbon steel up here. We talked about on building big how there's different materials, and different materials cost and their strength and how heavy they are. We can choose from different types of metal, such as high strength alloy steel or quench tempered steel. I can also change it from a solid bar to a hollow tube, each one having different cost and value. This right here says the size of the tube or the bar. Right now it's at 140 by 140. If I can take my selection tool here and I can select a member right here. This is member 18. Currently I have it set as a 140 size. If I change that, I can make it a 500. Look how huge that is. 500 by 500, but look what it does to my cost. Watch my cost. If I go back to my 150, or I'll even go here just for a second. Okay, it's 283, but if I put in a larger member, I'm at $350. That one little piece just cost $80,000 because of the size of it. Okay, but I just want to show you that you can adjust the size of that. Obviously, the bigger it gets, the more cost you get. Okay. The other thing that we talked about, one thing that's cool here is if I look at the member list here, member details, if you remember when we talked about compression and tension, and I gave you that example with that a piece of stick, that the longer the stick is, or the longer the member, when you compress it, it gets weaker and weaker. So this is showing you the member length right here. Member length in meters. This particular member, member number 1, is right here. The tension strength, doesn't matter how long the member is, the strength stays the same. It's like 700, right? So the strength stays the same there. However, the compression, the longer the member, you'll notice that the strength goes down and down and down and down. Okay? Then we had talked about that, the difference between compression and tension and the member length. Okay? This is a prime example of how this works. Now, I get my bridge all done. Okay? And I can go and I can do what's called a load test. Right up here, there's run a load test animation. I click on this button, and right now it's telling me your structural model is unstable. So I have a area, remember we talked about rectangles, how they're unstable? So I would need a cross member somewhere here. So I must have missed one somewhere. Oh, I missed quite a few. So I missed a cross member here and one here. Now I should have a stable bridge. And I do have a stable bridge. Oh, crash. Okay?
Yep.
So, here now, in lies the problem. We notice on the bridge, where there is red, that is a compression. Where there is blue, that is tension. So at the bottom of the bridge has a tension force going across it, literally pulling it apart. At the top of the bridge, we have compression. You notice on this, every member pointing in has a compression force, and every member going straight down here has a tension force. The darker the color, the closer it is to failure. But that's also being closer to just enough on the cost. There's no sense having a member that cost $20 or say even $80,000 when you really only need a $5,000 member. Okay, so we want to try to get as close as we can. So the darker the color is better. We just don't want failure like this one. So I can go back now, right up here to the drawing board view, and it's actually going to give me red lines on the members that failed, and it even shows it here. It shows the compression force, it shows the amount of force that it took and exceeded. Okay, so I can come in here now and I use my selection tool, and one thing that's handy is use your control key. Hold down your control key while you click the rest of these members. So I'm going to hold down the control key, and then I'm going to click on this one, each one of these that failed. And now what I'm going to do is I'm going to come up here and I'm going to increase the size of it. I can either go here and increase, like select another one, or I can also go right here and say increase size of selected member. I'll just go here and I'm going to go one. I'm going to go once. Well, no. You could see how 13, 18, and 19 all are fine now. They don't have the red indicator anymore. Or do they? No, they do. Sorry.
If it still has a red on the side.
I think if it still has the red, it's still going to fail. So let's take these and we'll go up another member. Maybe I'm forgetting. But either way, I'll take it up to 160 and now I'll test it again. Let's see what happens. Hey, all right. The bridge held. Okay. So now my initial cost right now is $319,000. Now what I'm going to do is it held. And I want to look at some of these that aren't very dark colored, and I might change them. So for example, these right here, they're fairly light colored. They both have tension forces on them. I think I'm going to change it to a smaller member to save some money. Let's try this out. So these two right here, I'll hold down my control key and select both of them. I'm actually going to even try, let's try a hollow tube. I'm going to change it to a hollow tube, maybe a high strength steel. I'm watching the cost over here, see what's happening. And I'm going to take it down to 65. I just dropped about $4,000. I don't know if it's going to work. We could try it. I'll test it. Ooh. As it grows across, it starts experiencing a compression force. You see that? So it did fail. So I'll have to go back and tweak it. But all in all, that's how you're going to make a bridge. You can build it however you want. At this point, I can even click on these. I can click and drag them and move them around. Okay. Do whatever I want. Test it. It's going to say it's unsound. I can't do it. But all right. That is that.
Yoy! Yeah! Wow. Hi. Yoy! YOLO!